one of the topics we wanted to talk about today was system resiliency, specifically when a system has to go through operating system updates, various things go down, you lose access to your cameras, your recorded video. It's a big concern for a lot of customers for NVRs in the traditional sense. BVMS is a little different, and it has some different options to afford better resiliency. So I wanted to ask you about these components that we have here in front of us today and walk me through some of this.
Sure. So Mike, any manufacturer out there of a security system is, usually everybody's talking about the new feature sets and everything like that. There's very few times where they're out there talking about what happens when you do have either scheduled updates or worst case failures, right? Mm-hmm. And that's what we're going to cover today. And most importantly, how BVMS, the BVMS environment responds to those failures or scheduled updates in that environment. I think it's important to point out that based on what we have here on the table, just 2 servers that by themselves can support up to 2,000 cameras. So that just that in itself is completely different than what your traditional NVR environment would be. But what we're going to do is we'll introduce each component down the line, and then what we're going to do is walk through basically putting these into a failed state or a communication loss and seeing how that comes out on the operator client side.
All right, excellent. Well, it looks like we've got the management server, the VRM service, some cameras, and a nice SCSI setup over here. Do you want to tell us a little bit about the BVMS management server?
Sure. So the BVMS management server is responsible for all configuration of the system. It's also where all the licensing lives. Okay, so as far as that aspect of things, everything is there. Consider it like the mothership, with it basically then disseminating everything down to the other components in the system.
Okay, great. Next up we've got VRM, right? The Video Recording Manager.
Yep.
We more or less refer to this as the traffic cop. It gives the instructions for the cameras and allocates the storage for them, so they know where to direct all the traffic for storage, and it is able to recall that information as well for playback.
That's correct. Another important part of VRM is to maintain load balancing, so evenly dispersing cameras across storage targets, making sure everything is even, but not only that, but also facilitating cameras and recording when a storage target is down.
Right,
so we'll see
very
that.
important.
The other 2 things, we have a PTZ camera here, IP PTZ camera, the MIC, and we have a IP fixed camera, the 8000i, just to kind of show the difference from the client perspective on what happens when these failures occur. And then we have 2 storage appliances here to simulate what happens and how VRM handles the unforeseen incident where one target goes down where is actively recording cameras, right? So can't always prevent it, but here today we're here to talk about how this system responds and its resiliency that's built in.
All right, perfect. Well, let's take a walk around. We'll start looking at some resiliency and unplugging some of these and seeing what happens.
Okay, so Mike, first thing we're going to take down is BVMS management server. Like I said before, it's responsible for all the configuration delivered to every component in the system. Mm-hmm. But what we're going to do is disconnect it from the network, simulating any type of event, right? Either whether it's an update where it's currently not communicating, or the unforeseen happens where something in that rack, if it's physical or if it's a virtual, like anything, right? If it goes down, it's not talking. What happens and how does that affect our operators?
Right, right.
So Mike, I'm going to go ahead and ask you to remove the network cable from the management server. And what you're seeing now is the operator client interface right now. We saw that it was inactive, everything was actively recording. We don't have any odd icons or anything. Here in a couple seconds, we're going to see the status change, where we'll see that we have a communication loss to the management server.
Oh yeah, I can see that it changed right there, both in the logical tree and up top.
Yep, so we get a notification across the top that there's no connection to the server. We see here on the logical tree that the server state is disconnected, and we are on the status of each device is unknown. And that's normal. So there's a few things that the management server is responsible for maintaining, right? Obviously, you're going to have some kind of loss, but not to the point where you'll notice during all of that, live video never disconnected.
Right.
But there are some things that we will lose during this downtime. What are a couple of those things?
Yeah, there's a few things to be kind of aware of that you're going to lose, right? It's your system alarms coming from the management server for any of your preset alarms that may be going off on those devices. General device status, because that is pinging the server for the devices themselves, right, which we saw. Analog PTZ control, you don't have the throughput for that, but an important note is for IP PTZ, you do retain that control. So I think that's a pretty important distinction and speaks to the value of IP in that situation. Also, you'll lose decoder control. Things you may be surprised to learn that you retain, again, is your live video and all of your playback. So to your operator, otherwise, they can really continue their job and be notified of any kind of incidents that may be happening, or go back and do an incident report investigation if they need to.
Sure. So let's show a couple of those things that you just mentioned, moving back here. We're still in a disconnected state. Like Mike mentioned, we still retain IP PTZ control. There's no loss there. We still have live video from our fixed camera. We're going to go ahead and hop into playback mode. We're going to drag these cameras over. You notice our timeline populates. I'll go ahead and we'll jump to the latest recording. And I think a key takeaway here is we have all of our recording here, and you'll notice that the timeline is continuing to update. So with the main server down, we're still maintaining operation.
So as the blue continues to fill in, right, that's our recorded video.
That's correct. Go ahead and clear this. We're going to hop back to live. So Mike, now we're going to kind of show you what happens after BVMS management server has regained connection to the network.
Okay.
So if you can, let's go ahead and reconnect.
All right.
So now that the management server is back online, we'll just give it a couple seconds here, and then what we'll see is that the status clears and goes back to normal.
Oh yeah. And
we start seeing events come in.
Yep.
We see our recording state is back. We also see that the server state is connected and up to date. We also lost that notification at the top that it was down. So we're now back to a functional system for the operator.
Excellent.
Next piece of this is we're going to take down the video recording manager. And again, I just want to remind everybody, this could be something that was scheduled. You know, maybe both your servers are in a group that's going to apply an update at the same time, right, overnight.
Doesn't have to necessarily be a failure.
Doesn't have to necessarily be a failure, but I think it's important that we show how the system responds no matter what that case is, right?
Yep.
So what we'll do is I'm going to go ahead and ask you to disconnect the VRM server from the network.
Yeah, absolutely.
And what we're looking for here is a notification that VRM has been disconnected. There it is there. Just came in. That came in because, again, management server is online. Now you'll notice here with VRM, which is, like Mike said, in charge of all the video recording, our recording still has not stopped on the cameras. Go ahead and prove that by going into replay. Now you notice something a little different here. In each one of these cameos, there's an indicator here that says E in red. So what we're going to do is discuss what the system's doing right now. So Mike, we have VRM server offline. We see there's clearly a difference in the client side of things, but I kind of want to discuss what's happening in the background. Mm-hmm. So once VRM is down, you're not completely severed from your replay recorded video. What's the system doing now in the state that we're seeing it?
The cameras are actually working in the background to buffer that information and then send that through VRM to the iSCSI target.
Yeah, so the way the system works is the cameras are all given basically a instruction on where they need to be recording. So they already know where they're going to be recording if the VRM server were to go down. Now, what's built into the BVMS environment is VRM can actually go down for, by default, 4 days, configurable up to 7 days. And the cameras will maintain their recording instruction that VRM has already provided them. So what's happening now is replay is being recalled back through the cameras. And I think it's important to say, even though that works, they're only able to remember a certain amount of information, right? So they have memory on board. They can recall what they've been writing to. Of course, your full retention time lives on VRM, so it's important to get that server back up as soon as possible. But the resiliency is built into where, even from the client side, we didn't see any interruption. We still have live, we still have playback, and we're still able to recall recorded video.
And the operator has a notification so that they can take a proactive approach to getting that VRM server back online, right?
That's correct, yep.
Well, we've taken a look at what happens when these go off independently, right? The management server goes off by itself or VRM goes off by itself. Is there a scenario here where both of these can go off at the same time? And if so, what capabilities do we still have available to us with the system from an operator perspective?
I think it's very important to show that. So what we'll do, and the reason why we have it set up like this is so that we can simulate this, right? We're having each component separated physically so that we can show everybody how this system truly performs. So what we're going to do is we'll connect VRM back up, let that reestablish, and then we'll go ahead and take both down.
Okay.
Okay. So Mike, go ahead and reestablish VRM. Now it's important to mention any replay sessions that were active. Obviously, once VRM is reintroduced, replay sessions, new replay sessions would be redirected to VRM. So ones that are currently open are still going to be using that mechanism. Okay. So what we'll do is we're going to hop back to live. Looks like VRM is back up, so we've got that notification. So Mike, go ahead and let's pull the BVMS management server and the video recording manager server off.
Okay.
So we'll give it a couple seconds now, and then we're going to get an influx of changes here. So we're starting to notice that the client is seeing the server has gone offline. You can see that our events have cleared out because we've lost that connection to the management server. If we switch over to replay, we'll see what we saw earlier where replay is being done from the devices themselves. But we have all the recorded video. And if we switch to live, we still have that PTZ control of our PTZ camera. We still have live video from both the fixed and the PTZ. And most importantly, our operator hasn't been interrupted.
Yeah, absolutely. Two of the main primary services for the entire solution are inoperable, yet our operator is still able to get live access and playback for all the cameras they have assigned to them.
Correct. And then the important piece here is this is being done with two servers, where there's not a failover server sitting around here somewhere that's taking the place of either one of these. The system is built in to be resilient enough to continue to operate in case something like this happens. So whether you're a mission critical site that or a smaller site, commercial, it really doesn't matter. BVMS, this is how it's built. It's not an additional feature. It's not an additional license. This is just how it operates.
Right.
So
all inherent in the strengths of the solution itself.
That's correct.
Whether you separate these services out into separate servers or you have them all contained into a single unit like a DVAR IP.
Correct. And we all thought it was important to physically separate them so we can show that more clearly instead of stopping the service and doing it virtually. So next part of this is what we're going to do is kind of show off how VRM handles itself in a condition or an unlikely condition where an iSCSI target is offline to the system, and how it handles reorganizing cameras that are recording to that device, and how it separates that out evenly.
All right, excellent. Well, we've got a couple of different iSCSI targets here, so shall we get VRM back up and running then?
Yeah, let's get BVMS and VRM back online, and then we can go ahead and show everybody that.
Okay, sounds good.
Okay, so our client has reestablished connection to BVMS management server. We got our device status back. We're going to go ahead and double check replay. We're not seeing our E indicator, which means that replay is going back through VRM, which is good. That means VRM is online. So now what we're going to do to show this next part is go into the configuration client. And the reason why we're doing this is to show everybody a live update of what is happening in the background when we do take down a storage unit. So we're going to select the camera. We're going to go to the recording management pages of that device. There's an icon on this device, if you hover over, it gives you real-time updates of what that device is doing. You'll see for recording 1, the recording, it's to an IP address. That's the IP address of the current iSCSI target it's writing data to, along with the data rate. So what we're going to do is have Mike disconnect the iSCSI target that both cameras are currently recording to, and then we're going to watch the live status update here on this side of things.
All right, great. So both devices are recording to this bottom unit here, right?
That's correct.
So we'll unplug that, and it should default then to the device on top.
Okay. So as we watch this, again, this is a periodic refresh. We will see at some point, or it just went, where the system is saying that the camera is not recording. And then we're going to see here that it does switch back to another IP. And then we'll kind of talk about what just happened before we dive into anything else. Okay, Mike, we've seen that the status update has changed and the recording has resumed. It took about 30 seconds, but we'll notice that the recording target that the camera is referencing is now .192, so that's a new target.
Oh, great. Okay,
so
it's good to see it switch over.
And that's built into VRM. So VRM's job is to not only load balance across all of your available iSCSI storage devices automatically, but it's also responsible for reorganizing, like I was saying, any devices that were recording to a device that just went offline to the system. So that happens behind the scenes. There's no manual intervention that needs to happen from a user or administrative perspective.
Okay. You mentioned that it went down for about 30 seconds and it said not recording, right? That could be an important 30 seconds where something could happen. Can you speak to a little bit what's happening in that gap of time there?
Yeah, sure. So even to take this a little further, the way that the system operates is the cameras, if we're set up end-to-end Bosch cameras will actually retain video internally and write that information to their memory. And then what we should expect now when we go back into the operator client is when we look at that replay, we're not going to have a gap, because what it'll actually do is replenish that information back to the system. Okay. All right, so we're back into the operator client, and we see that the system is indicating the cameras are recording. Everything seems normal there. The important piece of this is what happened when we took that storage unit offline. We'll go ahead and hop to the front. So you'll notice that during this duration, over the past couple minutes, there is no gap that exists here in the recording. And that's because that data has been written to the camera during that time where it was switching over, and then that information was replenished back to the system.
All right, that was a great example of what happens when individual services go down with BVMS, right? there's clearly the resilience there in the system. If a single service or multiple services go down, that the operator can still retain their day-to-day workflow and responsibilities to maintain the surveillance of a property.
Yeah, Mike, I think the important takeaway here is in a BVMS environment, the goal is to make sure that the operators have eyes on, right? So we're not going to interrupt anything there, and it's important that operators or just the customer in general has incident response, right? And they can't do that if they have no cameras and they're blind, right? So BVMS with direct to iSCSI recording and the way the system overall functions delivers that and ensures that customers are able to do their job and respond accordingly.
Awesome. The most important thing I heard there, right, is that there's no loss of recordings. Regardless of which service is going down and the operator client is pivoting the way that it needs to, none of those recordings are lost in that transition, and they can all be gone back to and researched as needed.
Absolutely.
Okay. Well, thank you very much for your time today and getting all of this set up and walking through it with me.
Thanks, Mike. Appreciate it.
Thank you.